Let's do some homework examples. Let's find the most general antiderivative of square root of x. Now, I have to write that as x to the 1/2 power. So I can use the antiderivative power rule. So that's x to the 1/2 plus 1 over 1/2 plus 1. Remember power rule for antidifferentiation. So that's x to the 3/2 power over 3/2 plus a constant. So that's 2/3 x to the 3/2 plus a constant. Remember, when you divide by 3/2, it's multiplying by 2/3. Okay? Let you stop and process that for just a minute. Anti-differentiation power rule is you don't bring the exponent down and subtract 1 from the exponent. To undo that, you add 1 to the exponent and divide by that new exponent. Okay, most general antiderivative of x to the 5th. Add 1 to the exponent, x to the 6th, divide by the new exponent. You get x to the 6 over 6 plus c. Power rule for antidifferentiation. Most general antiderivative of 1. What do you differentiate to get 1? Just think about it. If the independent variable is x. It's just x, isn't it? Just x plus a constant is my answer. Now, could I use power rule for that? Sure. 1 is 1 times x to the 0. Or just, by the way, x to the 0. Because 1 is x to the 0. So, if you use power rule on x to the 0 for antiderivatives, you add 1 to the exponent, you get x to the 1, you divide by 1. X to the 1 divided by 1 is just x. But this is kind of common sense. What do you differentiate to get 1? It's x. You know that. Okay, how about the antiderivative of a sum? The antiderivative of x squared plus 1. Well, in section 5.4, in that table of indefinite integrals, they do tell us that the antiderivative of, or indefinite integral, same thing, of a sum is the sum of the antiderivatives. So I can write this as antiderivative of x squared plus antiderivative of 1. Antiderivative of x squared is x cubed over 3. Now, I've got plus a constant for this piece, and I've got plus a constant for this piece. But a constant plus a constant is just a constant, okay? So we'll only just put the constant on the end. Antiderivative of 1, we just figured out was x. Most general antiderivative, we need the constant on the end. You know, you don't have... In your head, you can use the antiderivative of the sums, the sum of the antiderivatives. But you don't have to write this step right here if you don't want to. You can go directly to this one. Okay? Indefinite integral of e to the x is just e to the x, right? Because you differentiate e to the x, or e to the x plus c. You differentiate e to the x, you get e to the x. Now, how about the most general antiderivative of 3x plus 1 quantity squared? Well, hopefully that first, probably the second Pencast, taught you that you can't just say that's 3x plus 1 cubed over 3. Remember the true-false? You get a wrong answer. Again, don't make these antiderivative rules say something they don't say. They tell me that the antiderivative of x to the n is x to the n plus 1 over n plus 1. But they don't tell me on that table of antiderivatives in section 5.4 what to do about f of x to the n. Don't make this rule say more than it does. I've got an f of x here, an x squared plus 1. It's not just, I'm sorry, I'm looked at the wrong place, sorry. Let you in on a secret here. My pen's run out of ink, so the pen still works, but you just can't see what you're writing. So, anyway, here I've got an f of x instead of just an x. Can't say that's 3x plus 1 cubed over 3. Remember the true-false? We did that and we got a wrong answer. What I need to do is rewrite this as 9x squared plus 6x plus 1. Remember, I did FOIL. And now, the antiderivative of a sum is the sum of the antiderivatives. I'm not going to write that stat. Also, I've got an antiderivative shortcut that says you can just bring constants out front. Just like with derivatives, you can bring constants out front. With antiderivatives, you can bring constants out front. So, bring the 9 out front. The antiderivative of x squared is x cubed over 3 plus antiderivative of 6x is 6x squared over 2. The antiderivative of 1 is x. Then I got plus a constant. So that's 9x cubed over 3. That's just x cubed. 6x squared over 2. That's just 3x. And I have my answer. If you differentiate this answer and then factor, you will get 3x plus 1 quantity squared. I failed to mention, you can know if your answers are right or wrong on these antiderivatives, on these indefinite intervals. Just differentiate your answer and see if you get the original function inside of that indefinite interval symbol. Okay? Now, how about if I have x plus 1 over x? I have to do some algebra first because this x plus 1 over x doesn't appear in my table of indefinite intervals in section 5.4 on page 403. I haven't anti-differentiated anything that looks like x plus 1 over x. Doesn't fit a rule. So I do some algebra. I write x plus 1 over x as 1 plus 1 over x. Remember, x over x is 1. I have 1 over x. So I need the most general antiderivative of that. Antiderivative of sums, the sum of the antiderivatives. The antiderivative of 1 is just x, or that is an antiderivative. And antiderivative of 1 over x is natural log absolute value of x plus a constant. If you differentiate this, you will get 1 plus 1 over x, which is then equal to x plus 1 over x. Finally, let's do a power. Y'all love powers, right? Sorry for my sarcasm there. The fourth root of x, a root here. The fourth root of x to the fifth is x to the 5/4. The fourth root of x to the fifth is x to the 5/4. So I rewrite my problem as finding the most general antiderivative of x to the 5/4. Using power rule, that's x to the 5/4 plus 1 divided by 5/4 plus 1 plus a constant. So that's x to the 9/4 over 9/4. To divide by 9/4 is to multiply by 4/9. So this is 4/9 x to the 9/4 plus a constant.